Question number 36. If n, 2n and 3n are the fundamental frequency of the three segments into which a string is divided, then the original frequency of the string is equal to. Now dear student, the original frequency is calculated by this formula, 1 by n1 plus 1 by n2 plus 1 by n3. So 1 by n original is equal to 1 by n plus 1 by 2n plus 1 by 3n. So you have to take the LCM, which is equal to 6n, 1 by NO, and that is equal to 6 plus 3 plus 2. So NO will get equal to 6n by 11. So the correct option is the first one. The question number 37 is two sources of the sound placed close to each other are emitting progressive waves given by equation y is equal to 4 sine of 600 pi t and y2 is equal to 5 sine of 600 pi t. An observer located near these two sources of sound will hear. Now see, the amplitude one is 4 and amplitude of other is 5. Therefore, I maximum to I minimum is equal to A1 plus A2 whole square over A1 minus A2 whole square. And see, one amplitude is 4 and second amplitude is 5. So this becomes 4x plus 5x and divided by 5x minus 4x. And that comes to be 81 by 1 as the intensity for maximum to minimum, called waxing and waning. And see, the one frequency is here, which is equal to 300 Hertz, omega 2 pi n, and second frequency here is 304 Hertz. So the difference in frequency is equal to 304 Hertz minus 300 Hertz, that is 4 Hertz. So what you hear? The observer hear 4 beats per second and the maximum to minimum intensity ratio is 81 to 1. And look at the option. The option 4 is 4 beats per second and intensity 81 as to 1 between wax and waning. That's true. Therefore, the answer to this question is option number 4. The question number 38 is, in a medium, a wave represented by equation y is 20 sine of 60 pi t minus 45x propagates. The phase difference between the two particles separated by a distance of 2 cm along the direction of propagation of wave is. Now, if you remember, the relation between the phase difference and the path is 2 pi by lambda, and the separation between the particles. And see here, delta x, the separation is given 2 cm, and this 2 pi by lambda propagation constant, this is k, 2 pi by lambda. So therefore the phase difference is equal to 40 pi multiplied by 2, and that is 80 pi radian. So answer is 1 to this question. Now let's move to question number 39. The time of reverberation of a room is 1 second. The time in second of reverberation of the room having all dimensions double to those of room A. Now see, according to Sabine, there is a formula for reverberation allowed. The T is 0.156, the volume of the hall, the area of the hall, and absorption factor of the room. It means T is proportional to the volume to the area. Now he says when the dimensions are double, so when the dimensions say L is double to 2L, therefore area automatically will become 4 times and the volume will become 2 cube, that is 8 times. So the new time period will be, the volume is 8 times the volume and area is equal to 4 times the original area. So this become equal to twice of the initial value. So T prime by T is equal to the 2. So initial reverberation time was 1 second, so it will become 2 seconds. So answer is 2. The question number 40 is, the speed of the wave pulse on 8 meter long string fixed at both ends is 20 meter per second. The frequency associated with the third overtone of the string. The length of the string is given equal to 8 meter. and the speed is given 20 meter per second. The fix at both end with the length L, so the fundamental frequency will be like this, and therefore this is node and this is node, so L is equal to lambda by 2. So L is given 8 meter, so lambda will be equal to 16 meter, and its fundamental frequency become V by 2L or V by lambda, and that is equal to 20 divided by 16. Now it's asking the third overtone. The frequency of the third overtone is the fourth harmonic, so this will be 4 times the original frequency, and that is equal to 4 into 20 by 16, and that is equal to 5 Hertz. And the correct option to this is option number 3.